These are the section 1.5 notes. So we've been looking at the unit circle, but sometimes we will need to find the value of trig functions for a point on the unit circle when we do not know what the angle is. So using these trig functions will help us find that. Think about our point on the unit circle. So if we have a point given x comma y, then we can think of a right triangle and thinking about how this bottom value is our x and this side is our y value. Since this is on the unit circle, we know that the radius is 1, so our hypotenuse of that right triangle is 1. So we can use this to fill in our trig functions. So sine opposite over hypotenuse, you want to think about SOHCAHTOA to help you with this. So opposite over hypotenuse, y over 1, so it's just y. Cosine, we'll get x, and then tangent is y over x, sine over cosine. And then our other functions are just our inverses. So 1 over y, secant is the inverse of cosine, so 1 over x, and then cotangent x over y. So we're going to use these values to help us find the trig values of this point. So t here is representing an angle, but we don't know what the angle is. It's a real number, and our point xy here is a point on the unit circle that corresponds to the angle t. Find the exact value of the 6 trig functions of t. So it says it's on the unit circle, but we need to confirm that the circle is a unit circle, so we need to check that the radius is 1. Well, if we think about how we just drew a right triangle on our last slide, if we need to confirm that our radius is 1, we can use the Pythagorean theorem to verify that. So plug in your points here, your x and your y, for A and B to verify if our radius, our c, equals 1. So we find negative root 39 over 8 squared plus 5/8 squared equals 1. So this is what we're asking ourselves. So if we solve this, we get 39 over 64 plus 25 over 64, which does equal 1. So we're good, so it is a unit circle. So now that we've confirmed it's a unit circle, we can use our x and y to solve for the trig functions. So I'm going to make a note, I'm going to switch colors here, make a note that my x value is negative square root of 39 over 8, and my y value is 5 over 8. So now it's just a matter of using those and simplifying. So sine of t is just y, so it's just 5/8. Cosine of angle t is just x. And then tangent of angle t, we think of y over x, so 5/8. We're going to multiply that by the reciprocal. And then we just need to solve this out. So your 8's cancel. And then remember, we need to fix this and not leave a radical in the denominator. So practice solving this by hand. You should end up with negative 5 square root of 39 over 39. All right, now thinking of our inverse functions. So cosecant of t is the inverse of sine. So all I'm doing is flipping my y. Secant of t, inverse of cosine. So we're flipping our x. But again, we don't want to leave it as a radical in the denominator. So when you work it out, we end up with negative 8 square root of 39 over 39. And then cotangent of t. And cotangent of t ends up being the reciprocal of tangent. We ended up getting square root of 39 over 5.